So what Leslie is pointing out is that in the absence of a world ensemble where all possibilities are actualized, you can't use the anthropic principle to explain away our surprise at seeing the fine-tuning of the universe. You still have to have some explanation for why those marksmen all missed. It's not enough just to say, well, if they hadn't all missed, you wouldn't be there to be surprised about it.
One guy tried to get around Leslie's analogy by saying that the guy who was about to be shot, after he heard the roar of the guns and he was still alive, he took off his blindfold, and there were 100 other condemned criminals, but one of them was shot.
Yeah, see, what he's trying to do is a world ensemble. He's
multiple.
Yeah, exactly, and that would be right. He's right. If you posit enough firing squads shooting at people that the incredibly infinitesimal possibility that they'd all miss would somewhere be actualized, then, yeah, the guy shouldn't be surprised that they all missed, because somewhere in the ensemble of firing squads and victims, one of them by chance alone would have missed. But that just illustrates my point, that the anthropic principle without the world ensemble won't do the trick. You've got to have the multiverse to generate all of those other possibilities. Now, as I say, multiply your probabilistic resources so that somewhere this infinitesimally improbable event is going to happen.
People who discuss this topic often refer to the work of Barrow and Tipler. Can you summarize some of the things that they said?
Well, Barrow and Tipler wrote a book called The Cosmological Anthropic Principle in 1985, which is just a masterpiece of compiling all of the evidence for fine-tuning in the universe. And they show how incredibly fine-tuned the universe is for our existence. And then they enunciate a couple of versions of the anthropic principle, as you say, and attempt to defend it. And I think that their own view does succumb to the criticism that I've just lodged, that the anthropic principle is invalid or impotent in the absence of this world ensemble. So the real question that is facing us today in this whole question of fine-tuning and how is it to be explained is the question, which is the better explanation? An intelligent designer of the universe, or a multiverse or world ensemble of universes, of randomly ordered infinite number of worlds? Which is the better explanation of those two?
In your new edition of Reasonable Faith, the book, you expand the chapter in dealing with this. What are some other things that you put in?
Well, what I point out is a couple of criticisms of the world ensemble hypothesis that I think make it less preferable to the design hypothesis. And one of these is fairly obvious, namely that if the world ensemble itself is to be a plausible scientific alternative to design, you've got to have some sort of a mechanism for generating the many worlds. You can't just say they're out there. You need some sort of a theory that would generate this world ensemble of an infinite number of randomly ordered universes. Well, the best shot at this would be inflationary theory. If the early universe were configured just right, then as the universe expands, there would appear bubbles within it of lower energy vacuum. And these bubbles could each then constitute a separate universe. These would be your little universes within the multiverse that spawns the bubbles. And if there were enough of these and they were randomly ordered, then you'd get your world ensemble. Now, the question is, what about the mechanism that produces these bubble universes? Is it fine-tuned or not? And if it is finely tuned, then obviously the problem hasn't been solved. The world ensemble gets rid of the cosmic designer only if there is no fine-tuning required for the world ensemble. And that is far from obvious. For example, the cosmological constant, which drives inflation, has to be fine-tuned to 1 part out of 10 to the 120th power. And there's no explanation of that. Also, in the best theory that we have of a kind of theory of everything today, M theory or superstring theory, the theory only works if there are exactly 11 dimensions. But the theory itself doesn't explain why the world should have 11 dimensions rather than any other number. So you have a kind of geometrical fine-tuning in this case in the number of dimensions. So it's not at all obvious that the world ensemble hypothesis has eliminated the need for fine-tuning. That's one problem. Here's another problem. As I mentioned earlier, the theorem developed by Borde, Guth, and Vilenkin has shown that the multiverse itself cannot be extended into the infinite past. There had to be a beginning to this multiverse, and ever since its beginning, it's been chugging away, producing these bubble universes. Now think what that implies, Kevin. If it had a beginning, then that means that there can only be as many universes in the ensemble as have been generated since the multiverse began. But in that case, it's going to be a finite number, not an infinite number, and therefore, given the incomprehensible improbability of the fine-tuning, there's no guarantee whatsoever that finely tuned universes will have appeared yet in the world ensemble of bubble universes. So you don't have an infinite number of randomly ordered worlds in the way that the multiverse hypothesis requires to explain away fine-tuning. So that's just a couple of problems. But perhaps the most damaging objection is the third one, which has been developed by theorists like Roger Penrose, mathematical physicist at Oxford University. What Penrose points out is that if we are just a random member of a world ensemble of randomly ordered worlds, then it is highly, highly probable that we ought to be observing a very different universe than the one we observe. For example, Penrose calculates that the odds of the universe having its exact thermodynamic characteristics is 1 chance out of 10 to the power of 10 to the power of 123, just an incomprehensible number. So that the odds that the universe would be fine-tuned in the way that we observe it to be are just incomprehensibly small. By contrast to that, what are the odds that the solar system would just pop into existence suddenly by the random collision of particles? Just particles jostling around would suddenly, boom, fall into the configuration of our solar system. Well, Penrose figures this out. He says it's about 1 chance out of 10 to the power of 10 to the power of 60. Now, that's an incomprehensibly large number, but it is infinitesimally small compared to 1 chance out of 10 to the power of 10 to the power of 123. In fact, Penrose says it's utter chicken feed by comparison. Now, what does that imply? That implies that if we are just one random member of a world ensemble, then as we look out at the universe, what we ought to be observing in all probability would be a universe no larger than our solar system, because that kind of world is vastly more probable than a finely tuned universe like ours. And therefore, our observations disconfirm the world ensemble hypothesis. It makes it very, very improbable that we are just a random member in a world ensemble. In fact, the current wrinkle in cosmology today has been to calculate what would be the smallest observable universe there could be. In fact, it would be smaller than the solar system. The smallest observable universe, and therefore the most probable observable universe to just pop into being from a random collision of particles, would be a universe which consists of a single brain which has the illusion of an external universe around it, that appears to see an external universe when in fact all that exists is just a single brain. And these are called Boltzmann brains, after the German 19th century physicist Ludwig Boltzmann. And therefore, if that is true, then in all probability, if we are just a member of a random world ensemble, each one of us ought to conclude that he is in fact a Boltzmann brain, and that your hands, your head, the world around you, the trees, the cars, other people, all of these are just illusions of your consciousness, projections of your brain, and that all that really exists is just you, your single Boltzmann brain. Now, if you don't think that you're a Boltzmann brain, if you think you're a respectable, ordinary observer in an external world, then you should conclude that, therefore, a world ensemble does not, in all probability, exist.